What's up, everybody? Welcome to another video. Hope you're ready to flex those brain muscles. In this video, I'm going to talk about the law of sines, but more specifically, I'm going to talk about the ambiguous case, because this seems to be where students struggle the most when it comes to solving triangles. This ambiguous case is like kryptonite to students. There's just a lot of confusion, a lot of questions, so I'm going to dedicate a video on doing some examples and hopefully clear some of that confusion and clear up and answer some of those questions. So I do already have a video or two on the law of sines. I'll link those right above here. But again, this video is going to focus on this ambiguous case, which is also known as side-side angle, or you can call it angle side-side. I have no problem with you calling it the ass case if you want to. I think I called it that in my other video. But again, the reason why this is so tricky and the reason why we call it the ambiguous case is because it's unclear on whether we have no triangle, one triangle, or two triangles. We have to do some investigating to find out. And normally what we do to find out is we just jump straight into using the law of sines and we see what happens. So I'm going to go ahead and start using the law of sines. I'm going to do sine of 40 degrees over 4 equals the sine of C, angle C, over 5. All right. So sine of 40 degrees, and make sure your calculator in advance, make sure your calculator is set to degree mode. Sine of 40 degrees over 4 equals sine of C over 5. Now I'm going to solve for the sine of C and take the sine inverse of both sides. So I can multiply both sides by 5. Okay, so I'm going to draw an arrow here. That means that 5 sine of 40 degrees, because when I multiply both sides by 5, this 5 cancels, the 5 moves over here, okay, over 4 equals sine of C. Now I can sine inverse both sides because I want to solve for this angle C, and I solve for an angle by using sine inverse. So I can sine inverse here, sine inverse, or arc sine, whatever you want to call it, sine inverse here as well as here, and that will get rid of the sine, and I'll be left with C equals sine inverse of what? This 5 sine 40 degrees over 4. 5 sine 40 degrees over 4. So I'm going to punch all this in a calculator. Just give me 1 second. All right, so when I punch this in the calculator, I get 53.46 degrees. So we know that we definitely have at least one triangle, because if we had no triangles, when we punch this in, we'd get some kind of an error, or up here we'd end up with something like sine of C equals 3 or -2, something that's not possible, that doesn't make sense. That's how we know there's no triangle. So that no triangle case is actually the easiest case to deal with, because we find out pretty quickly that there's no triangles. But in this case, we have at least one. So now how do we find out if there's two? What we do is we take 180 minus this angle, all right? And the reason why we do that is because let's think about what happened when we punch sine inverse into our calculator. Sine inverse, when we punch it into our calculator, again, the range of sine inverse, if we think back to a chapter ago, is from negative pi over 2, well, I'll say it in degrees, from negative 90 degrees to 90 degrees, right? That's the range of sine inverse. So when we take sine inverse of both sides, we knowingly restrict the possible angles we can get from negative 90 degrees to 90 degrees. And since we're dealing with triangles, we only care about positive angles. So really, when we punch this in, we're always going to get angles between 0 and 90 degrees. But what if it's possible to form a triangle using this information to form another triangle with an angle between 90 and 180, right? What if it's possible? We would never find out from a calculator. That's why we have to go and do this extra work, right? Because look, 53.46 degrees, that's somewhere in here. But remember, sine is positive in the first and second quadrant, right? So if we use this as a reference angle, we can take that same angle over here, this angle here, right? Which we find by taking 180 minus 53.46. That's why we do that, right? So we find this angle, and the reason why we care about that angle is because the sine of this angle is equivalent, is the same thing as the sine of this angle, right? And since we're looking to make this, right, we're looking to find an angle C that makes this true, then this could potentially be a second triangle. This could potentially be an angle C for a second triangle. So how do we find out if this works or if this doesn't? Well, when we do 180 minus this angle, let's go ahead and try that. 180 minus 53.46. So this equals 126.54, quick maths. All right, so if this angle, when I add it to 40 degrees, is less than 180, in other words, there's room for a third angle to form a triangle, then we have two triangles. And in this case it is. If I take 126.54 plus 40, that's 166.54, and there's still room to have that third angle to form a triangle with 180 degrees total. Another way of thinking of it is I could do 180 minus this, and if that's greater than 0, right? That's another way of thinking of it. But yeah, so in this case we do have two triangles, and let me go ahead and erase a little bit and clear some room so I can write out the information. All right, so here's the information we have so far. This is angle C for triangle 1. This is angle C for triangle 2. This is what we just found. So now we just need to find angle A for both these triangles as well as side A. So finding angle A is actually pretty easy because we know that all three of these angles have to add up to 180. So we can do 180 minus C minus B, and that will give us angle A for triangle 1. And then we just do 180 minus C, but we use the C for triangle 2 as well as minus B. So I can go ahead and do that. 180 minus 40 minus 53.46, okay? And that's going to give us, let's see, minus 93.46. That is 86.53, all right? So my angle A for triangle 1 is 86.53 degrees. And now I do the same thing to find angle A for triangle 2. I do 180 minus 40 minus 126.54. And this equals, let's see, what does this equal? 166. So I'm left with 13.46 degrees. So I have 13.46 for angle A. Now to find side A, I can't use Pythagorean theorem. This is not a right triangle. Don't forget that. I can't use Pythagorean theorem, but I can use the law of sines, all right? Since I have angle A, I can use the law of sines to find side A for both triangle 1 and triangle 2. So let me make a little space here. I'm gonna go ahead and use the law of sines again. I know this is quite the process. That's why a lot of students make mistakes with these problems. This is quite the process. So sine of, let's see, I'll use 40 degrees and 4. All right, sine B over B, 40 degrees and 4 equals sine of 86.53 degrees over A. This is how I'm going to find side A. So there's a cool little trick if you don't know it. I can flip both sides of this and it'll still be a true equation, right? So I can go ahead and do that, and then it'll be easy because I can just multiply both sides by sine of 86.53. So if I flip both sides of this, I'll draw a little arrow. I have 4 over sine of 40 degrees equals A over sine of 86.53 degrees. All right. And now I can multiply both sides by sine of 86.53 degrees. It's a little easier. Otherwise, you could cross multiply and do a bunch of steps, but I just want to show you all that cool little trick. You can flip both sides. It's still a true equation. So multiply both sides by that sine of 86.53, and I get 4 times sine of 86.53 over sine of 40 degrees. And this equals my side A. So if I punch this in a calculator, I get 6.2. All right. So side A for triangle 1 is 6.2. Now I just do the same process, but for triangle 2. So I am going to go ahead and erase and see if I can find side A for triangle 2. And then that's going to be it. I have the two triangles. And again, the reason why I just wrote down this information is because this information I'm given doesn't change. I guess I could write out ABC for both of these, but I'd just be copying down this information twice. Hopefully that makes sense. So, law of sines. How am I going to find side A? Law of sines. So I have sine of 40 over 4 equals, let's see, sine of 13.46 over A. I could have flipped both sides before I wrote it down, I guess, if I would have planned ahead better. Sorry about that, but I'm going to flip both sides. So 4 over sine of 40 equals A over sine of 13.46. Now I can multiply both sides by sine of 13.46. 4 times sine of 13.46 over sine of 40. which equals what? This equals my side A, and when you punch this into a calculator, you get 1.4. 1.4. And it makes sense that this side is really small because the angle across from it is really small as well. 1.4. And that's it. So given this information, we were able to find two triangles. So this is a two triangle case. Let's go ahead and do one more example. All right, let's do one more example. Same exact thing. We're just going to go ahead and jump right into using the law of sine. So I'm going to write out sine of 52 degrees. Sine of 52 degrees over 7 equals sine of angle B over 6. I'm going to multiply both sides by 6. Okay, so I get 6 times sine of 52 degrees over 7 equals sine B. And you could punch this in your calculator and get a value. You could do that. There's nothing against that. I wait until the very end and just punch it all in my calculator at once, but you could punch this in, get a value, write that out, then do sine inverse of both sides if you're more comfortable doing that. So sine inverse of both sides now. Sine inverse, and that gives me what? Angle B equals sine inverse of 6 times sine of 52 degrees, 6 sine 52 degrees over 7. So when I punch this in a calculator, what do I get? Let's find out. All right, I get 42.49 degrees. So we know we definitely have at least one triangle, but now we need to go and find out if we do have that second triangle or not. So I go ahead and do 180 minus whatever angle we got, which is 42.49 degrees. 42.49, and I'm trying to see if this angle works. Basically, I'm trying to see if I can take whatever this angle is, which happens to be 137.51, and see if I can add this angle to it and it be under 180. So I basically have room for that third angle to form a triangle. In this case, clearly I don't. When I add 52 degrees, I'm around 189. I spill over. I don't have room for that third angle to form a second triangle. So in this example, I only have one triangle. So I'm going to go ahead and erase this. So we have our angle B. So really, what do we need to find from here? Just angle C, which is pretty easy to find, and then side C, which I can use the law of sines to find. So angle C is going to be 180 minus 52 minus 42.49. So angle C equals 180 minus 52 degrees minus 42.49 degrees, because all the angles have to add up to 180. So if I have two angles, I can find the third by just subtracting them from 180. So this gives me what? That's 94.49. So what's left? 85.51 degrees. So this is angle C. Now I just need to find side C. So again, I can use the law of sines. So I can do sine of 52 degrees over 7, so that's sine A over A, equals sine of, let's see, I'm going to use C because I'm going to solve for side C. So sine of 85.51 degrees over C, and I want to solve for that side C. So I can flip both sides again. Let me draw the arrow here. I may run out of room here. I have 7 over sine 52 degrees equals C over sine 85.51. Now I multiply both sides by sine of 85.51. C equals 7 times sine of 85. Hopefully I can see down here. 85.51 over sine of 52 degrees. When I punch all this in a calculator, what do I get? I get 8.86. 8.86. So that's my side C is 8.86. And now I've solved this triangle. I have side A, B, and C, and angle A, B, and C. There is one single triangle that works. So here's another example of the law of sines ambiguous case, side angle. So hopefully this video helped. If it did, make sure to leave a comment and like the video as well. Stay tuned for more. Hit subscribe if you enjoyed, and keep flexing those brain muscles. I'll see you on the next video.